Assalamualaikum warahmatullahi wabarakatuh. Today, we from group 17, we will present about the application of fluid mechanics in aerospace engineering. Our team first is Hanis 220180, and then Zakri 220170, Shazwani, and last is Wang Du Sam. Okay, what is aerospace engineering? Aerospace engineering is the primary field of engineering concerned with the development of aircraft and spacecraft. It has two major developing branches. First, aeronautical engineering, and second, aeronautic engineering. The word nautical means ship. Okay, this is the aerospace engineering. And ada has two type, two major, aeronautical and astronautical. Okay, how can fluid mechanics apply in aerospace engineering? Fluid mechanics successfully help aerospace engineers to build machines that can fly in the sky and even outer space. There are many examples in this world of aerospace engineering that can relate to fluid mechanics, especially an aeroplane. Okay. Part of an aeroplane, such as wing engine, is designed to provide maximum efficiency for aeroplane to fly in the sky.
Winglet of aircraft. A winglet is a device that deals with the features of airflow and its effects. Importance of the technology. Winglets are vertical extensions of wingtips that increase the fuel economy and cruising range of an aeroplane. Winglets, which are designed as a miniature airfoils, lessen the aerodynamic drag associated with vortices that form at the wingtips as the aeroplane passes through the air. Reduce wingtip drag, reduce fuel consumption, and increases range. Another possible advantage of winglets is that they lessen the strength of wake vortices. Those trail behind the jet and pose a risk to other planes. These variables heavily influence the minimum spacing requirements between aircraft operations at airports. Basic operational theory. Winglets are designed primarily to improve the overall efficiency of aircraft. A winglet is a device designed to increase aircraft economy by reducing lift-induced drag created by wingtip vortices. At the tip of its wing, there is a vertical or angled extension. So here the figure of wingtips vortices. Benefits to human. First, it reduces the fuel cost. Second, winglets boost airline earning or lower passenger rates. Third, reducing environmental impact. Disadvantages. Though winglet of an aeroplane provide benefits, it does have disadvantage, which is increases the chance of getting hit at the side of the aeroplane. Designs. Blended winglets. So we can see the figure of blended winglet here. Second, wingtip fans. Winglet of this variety extended from the wingtip in both directions, outward and downward. So we can see outward and downward. Next design is racket wingtips. Racket wingtips appear to be simple wingspan extension, but they have a greater degree of sweep than the rest of the wing. So we can see the record wheelet here. Specification. Wheelet geometry. First, wheelet aerofoil. The wheelet aerofoil can be the same as the wing, or it can be modified to meet the requirements for lift and drag. Wheelet height. The optimal effected drag and profile drag relationship are controlled by the wheelet height. Third, twist or sweep. The twist sweep angle has a similar effect on the wheelet and tailors the load distribution. Next, toe angle. The toe angle governs the total loading of the winglets. It has an influence on the load distribution on the wing and is suited for a single flight condition. Next, chord distribution. Small chord distribution requires a high coefficient of lift, whereas when the chord distribution is too large, the load of the winglet causes the outboard part of the wing to stall early. So we can see the figure of specification wheelet geometry. Here the twist, toe, sweep and cut. So the theories, wheelets are largely used to boost the overall efficiency of aircraft in today's aviation environment. A wheelet is a device designed to increase aircraft economy by reducing lift-induced drag created by wingtip vortices. At the tips of each wing, there is a vertical or angle extension. Wheelets increase efficiency by spreading the shared wingtip vortex, which minimizes lift drag and increases the wing lift over drag ratio. Wheelets improve a wing effective aspect ratio without significantly increasing structural stress and hence required weight. Wheelets are being built into the majority of modern transport aircraft. Aside from selecting a wheelet airfoil, 5 key parameters had to be chosen to optimize the design. First, cant angle. Second, twist distribution. Sweep back, taper ratio, ratio of winglet root chord to tip chord. Here the aerofoil geometry. Design parameter. Shape of aerofoil can maximum lift coefficient. Chord length of aerofoil, minimum drag coefficient. Thickness of aerofoil can maximize lift angle. Next, aerofoil chamber can lift curve slope. So we can see the airfoil shape, which is symmetrical and asymmetrical. This is the chord ratio. Aerodynamic force. You can see the figure of aerodynamic force, which is consists of lift, thrust, gravity, and drag. So we can see the lift formula here. Rho is density of the fluid through which wing is moving. V, the speed of wing relative to the fluid. A, the area of wing. Cl is coefficient of lift. Next, the drag formula. Rho is same as before, density of the fluid through which wing is moving. V, the speed of wing relative to the fluid. A, the area of wing. CD is coefficient of drag.
I will present about the aerofoil. So how does airplane fly? Airfoil is a cross-sectional shape designed with curved surface that produce bigger lift but small drag during flight. So there are two main forces that act to the part which are the lift and drag forces. Working fluid, which is air, is moving through the wings and produce lift and drag forces. Concept of airfoil is that the air moves faster at the upper of the wing and produces low pressure, but at the bottom of the wing, uh, air moves slower and it will produce bigger pressure, so the aircraft will be lift in the air. The importance of efforts. So it is highly efficient lifting ships. It is also able to generate more lift than generally such plates of the same area. So and it is also able to generate lift with significant less drag. The figure shows that the efforts of the aircraft wings and other aerodynamic engineering applications. So this is what actually how planes fly. So the basic operational theory, there are four main forces that act in to the aircraft. First is the lift. Lift is the force that the wing exerts as it passes over the beneath of wing, it is known as lift. And during flight, lift often supports the aircraft. Before the aerodynamic forces of lift is useful, it is crucial to consider how the air is moving around the aircraft, particularly the wing. And next, the weight. Weight is a result of gravity's downward pull. Due to the fuel consumption reduction and other variables that affect the aircraft's weight, the weight of aircraft changes at the completion of each trip. The thrust, the force that propels an aeroplane forward is known as thrust. When the engine rotates the propeller, thrust is retreat, and drag is resisted by the forward acting force. And last, the drag. Drag slows the aircraft and restricts the forward thrust speed. When you walk against a strong wind, you are typically experiencing drag. In other words, it behaves in the inverse direction of the flight. The benefit of airfoil in human life, it is a thick airfoil creates more lift than flat airfoil at same speed, and it gives low takeoff and landing speeds. A thick airfoil can accommodate large fuel tanks and landing gear, uh, and commercial aircraft we use an airfoil that is optimized for cruise flight in terms of lift to drag. They will extend the flaps when they need to slow down and land, which increase the camber and bigger wing area. The stall speed is lower, but the drag is high, making landing safer. The design of airfoils, and the design is basically based on the function of the aircraft. This figure shows that the aircraft part, which is the leading edge, is in front of the tip of the wing, and at the back is the trailing edge, and the chord line is the line where between the leading edge and the trailing edge and the camber. The shape and design of airplanes' wings are typically determined by intended use. A thick airfoil is most effective for low-speed flight, whereas a thin airfoil is more effective for high-speed flight. Airfoil typically fall into one of two categories, which is conventional flow and laminar flow. Laminar flow airfoils were initially designed to accelerate aircraft flight. The leading edge of the laminar flow wing is also more pointed than that a conventional airfoil, and it is upper and lower surface are nearly symmetrical. The the laminar flow airfoil greatly reduces drag since it requires less energy to slice through the air. Because the camber of the wing is more gradual from the leading edge to the point of maximum thickness, the pressure distribution of the laminar flow wing is more uniform. However, commercial aircraft still use the conventional airfoil because it is less likely to stall. So next slide is about the aspect ratio. So aspect ratio is defined as wingspan power and of two divided power of two divided by the area of the wing. So high aspect ratio wings have skinny and long span, but low aspect ratio wings stubby and have short spans. So what is the spans?
Hi everyone, I'm 2200147 Wongdu Sam, and I'm going to present about aero engine and how fluid mechanics apply in this subtopic of aerospace engineering. Next, what are the importance of an aero engine? Well, first of all, the aero engine is made of high heat resistant materials. Only the best materials such as carbon fiber, Kevlar, and fiberglass are used in this design. With this being said, the engine will be able to generate more thrust to provide aeroplane with high velocity. The higher the thrust force, the higher the lift force. Now, I will explain about the turbofan engine basic operational theory, which is most commonly used by commercial aircrafts. Firstly, air is being sucked in and it goes two ways. The first way is to bypass the combustor, compressor, and turbine. For the second way, it goes into the compressor, combustor, and turbine. For the first way, the air is sucked in and bypass the propulsion system and flow through a narrowing duct to produce a high velocity at outlet. For the second way, the air is first compressed by low pressure compressor. Then it is further compressed by the high pressure compressor before being combusted in the combustor. The combusted air will then flow to the high pressure turbine. Lastly, the air will flow from high pressure turbine to low pressure turbine before exiting through the nozzle of the exhaust. What are the pros and cons of a turbofan? The turbofan has a bypass ratio, so the good news is that the turbofan can help save more fuel and reduce noise. However, the bypass ratio produces lower thrust force compared to other engines such as a turbojet engine. In this slide, I'm going to show the comparison in design and specification of a turbofan engine. In a conventional turbofan, a single shaft connects the fan, the low pressure turbine, and the low pressure compressor. In this configuration, the maximum tip speed for the larger radius fan limits the rotational speed for the lower pressure shaft and thus the lower pressure compressor and turbine. At high bypass ratios, the tip speed of the lower pressure turbine and the lower pressure compressor must be relatively low, which means Extra compressor and turbine stages are required to keep the average stage loadings and therefore overall component efficiencies to an acceptable level. Lastly, how can fluid mechanics apply in this turbofan engine? We know that every action has an equal and opposite reaction force. The imbalanced force created by the air in the backward direction causes the airplane to have a thrust force forward. To move an airplane through the air, thrust is generated by the propulsion system and the bypassed air. The main equation of the thrust is F equals to the thrust of fan plus the thrust of core and plus the product of the bypass ratio and the core mass flow rate and the fan velocity. The equations to get the values are as shown in this slide. That is all from me. Thank you.